Thymus is primary lymphoid organ located in thoracic cavity behind the sternum and in front of pericardium. Thymus is active till puberty and helps in maturation of T lymphocytes. Differentiated T cells leave the thymus and get deposited in T cell dependent zones of secondary lymphoid organs. In adults, it gradually involutes and becomes fibrofatty tissue. Thymus is bilobed organ. When small part of it is processed for histological section, it shows small lobules. Every lobule has its own cortex, which is darkly stained, and it shows medulla. Medulla is lightly stained. Interestingly, medulla of all the lobules are continuous, and it's one. Here it is capsule. It sends septae or trabeculae inside, which divides into different lobules. Skeletal framework of thymus is different from spleen and lymph node. Let us quickly recall how it is in spleen and lymph node. There is outer fibrous connective tissue capsule and trabeculae which run deeper from the capsule. Parenchyma is supported by meshwork of reticular fibers in spleen and lymph node. But in thymus, parenchyma is supported by meshwork of reticuloepithelial cells, not by reticular fibers. Here we see capsule, trabeculae, network of epithelial cells, they are reticuloepithelial cells. Thymocytes are densely packed in the cortex of the lobule and they are sparsely arranged in the medulla. Let us zoom in. Thymic capillaries in the parenchyma are covered on their outer walls by reticuloepithelial cells. This is how they form blood-thymic barrier. This barrier protects the thymic parenchyma from antigens which can take entry from blood. This is how thymus is antigen-free zone, which is necessary for maturation of T lymphocytes. In the medulla, degenerating reticuloepithelial cells can form concentric lamellated bodies, Hassel's corpuscles. These are features of identification for thymic tissue. This is how they appear: concentric eosinophilic lamellated bodies. This shows thymocytes or maturing T lymphocytes supported by reticuloepithelial cells. This is H&E stained thymic tissue, shows capsule, trabeculae, dividing the thymic lobe into different lobules. Every lobule has its own cortex, darkly stained, and medulla, which is lightly stained. Medulla is continuous in all the lobules, and medulla shows Hassel's corpuscles. Reticuloepithelial cells are not seen in this power. Brief the development of thymic tissue. Reticuloepithelial cells are derived from endodermal pouch of third pharyngeal arch. They form a meshwork of these cells like a sponge. The gaps between these cells are occupied by young B cells which are derived from bone marrow. These B cells are precursors for maturing T cells of the future. How lymphocytes enter or leave the thymic parenchyma. Among the capillaries of thymic parenchyma, the post-capillary venules at the junction of cortex and medulla show cuboidal endothelial cells. In between these cells, the young B cells are selectively permitted into the parenchyma of thymus. First, they move to cortex. As they mature, they migrate to medulla. After complete maturation, they leave the thymus through the same sites. There is one more way for the matured T cells to leave the thymus. They are efferent lymphatic vessels. Yes, thymus has efferent lymphatic vessels. It doesn't have any afferents. How does T lymphocytes mature in thymus? For the T cells to call them as completely matured, they have to give two exams in the thymic school. First exam takes place in thymic cortex, where T cells are exposed to major histocompatibility complex proteins by reticuloepithelial cells. T cells have to recognize these proteins. If they recognize and bind, they are taken in. If they don't recognize, they are going to die by programmed cell death. This is called positive selection. Such selected T cells are taken inside for second examination in thymic medulla. Here, our own body proteins and their antigens are represented by reticuloepithelial cells as well as dendritic cells to these maturing T cells. Here, nature expects them not to bind to our own self antigens. If they bind, they are going for programmed cell death by macrophages. If they don't, they are taken in. This is called negative selection. Like this, positive and negative selection happen in cortex and medulla respectively, and passing percentage of T cell is only 2%. Finally, cluster of differentiation gives rise to two types of cells, CD4 cells, CD8 cells. They are different in their cell surface proteins. CD4 cells are helper cells, CD8 cells are cytotoxic cells. In the thymic school, the maturing T lymphocytes should not be exposed to any antigen. That's the reason nature has provided blood thymic barrier. And in some conditions, where T cells still recognize our own body proteins as foreign, they can cause autoimmune disease.